In this video, I want to have a look at normals and parabolas in the context of parametrics. So once again, we're going to have a look at our basic parabola, which is x squared equals 4ay, or in parametric form, it's x equals 2at, y equals at squared. So first we're going to go through and find the equation of the normal to the parabola at this point here. So we're trying to find the equation. So we're going to follow the same process we did when we were looking at tangents. The first thing we're going to do is find the gradient at this point, and then we can use the point gradient formula. So the point gradient formula is y minus y1 equals m outside of x minus x1. Again, our x1, y1 are these 2 points here, but we need to find our m. So if we start with this basic one, we can rearrange that to y equals x squared over 4a, which means that our derivative would be 2x over 4a, or just x over 2a. Now at this point, our gradient, so our m, is going to be 2at over 2a, which would give us just t. So that's telling us that t is the gradient of the tangent at that point, but that's not what we're after in this video. In this video, we want the tangent of the normal. So if the gradient, we'll call it m1, if the gradient of the tangent is t, then the gradient of the normal is going to be minus 1 over t. So this is the gradient we're using, so we can put that in this formula. So we're going to have y minus at squared equals minus 1 over t outside of x minus 2at. I just ran off the screen, I think. But we're going to have yt minus at cubed equals minus x plus 2at. So I've multiplied everything by t, and I've expanded that bracket out as well. Now if I move all of that onto, all my x's and y's onto one side of the equation and everything else over the other side, I'm going to have x plus ty, or yt, it doesn't really matter which way around you write it, is going to be equal to at cubed plus 2at. So this equation is again on your formula sheet, so we'll write it over here. All right, now I'm going to have a look now if instead of giving our point in this form, we're just given any point that lies on the parabola, x1, y1, and we want to find the normal at that point. So again, going through that same process, once we get up to here, instead of subbing in 2at, we'll sub in x1. So for us, our m1, the gradient of our tangent, is going to be x1 over 2a, which means that the gradient of our normal is going to be minus 2a over x1, so the negative reciprocal. Now that we've got that, we can substitute into this form here. So we're going to have y minus y1 equals minus 2a over x1 outside of x minus x1. So this is the formula that's on your formula sheet if you're given a point in the form just x1, y1. So in our last video, we looked at equations of tangents, and now we've looked at equations of normals. I want to have a look at an example of doing both of those things. So our example asks us to find the equation of the tangent and the normal to x equals 8y, so that's our parabola, at the point 4t, 2t squared. So we've got our equation of the normal here. Our equation of the tangent at the point 2at, at squared, was given by y equals tx minus at squared. So we're going to use this one and this one to find our two equations that it's asked for. So the first thing we need to do though is we need to find this value of a. We can do that in two ways. We can do it by looking at this original equation or looking at our points. If we have a look at this general form is usually x squared equals 4ay, which means that 4a has to be equal to our 8, which also means that a has to be equal to 2. So we could have looked at that here as well. Normally our x-coordinate is 2at, so if in our case if that's 4, then a has to be 2, and you can also see it in this y-coordinate as well. So if a is 2, then we can substitute that into these equations. So for our tangent, we're going to have x, sorry, wrong one, looking at the wrong thing. We're going to have y equals tx minus 2t squared. And for our normal, we would have, which is here, to have x plus ty equals 2t cubed plus 4t t. So those are our two equations that the question has asked for. All right, the last thing that I want to have a look at in this video is the intersection of normals. So if we have a normal to the parabola at the point P, 2AP, AP squared, and we also have another normal at the point Q, I want to see where they intersect and find the coordinates of that point. So if we have a normal going through this point, we know that its equation is going to be in this form. So we would have x plus py equals AP cubed plus 2AP. And if we had the normal going through the point Q, we'd have x plus qy equals a q cubed plus 2aq. So if we call those equation 1 and equation 2, we want to solve those simultaneously to find where they intersect. So I'm going to go 1 minus 2, and that's going to eliminate my x's. So I'm going to have py minus qy equals AP cubed minus AQ cubed plus 2AP minus 2AQ. Now we want to make y the subject of that, so I'm going to factorize out y as my common factor here. So I'm going to have y outside of p minus q. Now I'm going to factorize this in two sections. I'm going to pull out my a as a common factor in this section. So I'd have a outside of p cubed minus q cubed. And that's the difference of two cubes, which we can use in a second. And I'm also going to pull out 2a here. So we'll have p minus q there. Now if I factorize out this bit, I'm going to have y outside of p minus q. That's going to equal a. I'm going to have p minus q, p squared plus pq plus q squared plus 2a outside of p minus q. Now to get y on its own, I'm going to go through and divide everything by p minus q, which is going to divide through there, and over here. So I'm going to have a outside of p squared plus pq plus q squared plus 2a. Now I can also, if I pull the a out of this term, I can chuck my 2 in my bracket there as well. So I'm going to have a outside of p squared plus pq plus q squared plus 2. All right, so that's a bit gross, but that is my y-coordinate of the point of intersection. I now also need to find my x-coordinate. So that means I'm going to substitute this whole thing into either equation 1 or 2. So I'm going to make myself some room over here to do that. Okay, so if I sub that into 1, I'm going to end up with x plus p outside of this whole thing. So that's looking here, that's good. That's going to be equal to AP cubed plus 2AP. So I'm going to get the x on its own, which means I'm going to subtract this whole thing from this side of the equation. And while I do that, I'm also going to expand it all out. So I'm going to have x equals AP cubed plus 2AP. Now all of this is going to be subtracted. So I'm going to have minus. Now I'm multiplying by p and a when I expand this out. So I'm going to have AP cubed minus AP squared q minus APQ squared minus 2AP. Now my 2AP and my minus 2AP are going to cancel, and my AP cubed minus AP cubed are going to cancel as well. So then we've just got this bit. So I'm going to pull out a minus APQ as my common factor. So I'm going to have x equals minus APQ outside of p plus q, because I pulled out the negative, so that becomes a positive then. So that's my x-coordinate. So that means the point of intersection of the normals at these points is given by minus APQ, p plus q for the x-coordinate. And then for the y-coordinate, we're going to have a outside of p squared plus pq plus q squared plus 2. So that is the point of intersection. So that's having a look at normals to parabolas.